Assalamu alaikum wa rahmatullahi wa barakatuhu, friends. Welcome back to my channel. In video number 1073, I repaired this power supply and I detected MOV damaged. Metal oxide resistor damaged. This one. And I received comment from my viewer. Can you explain how to select correct MOV for protecting a circuit running on 230 volt? In last video, I discussed the basics of surge protection. What is surge protection? If you have not watched that video, I will suggest to watch that video. Video number is displayed on the screen. Then you can continue to this video. In the first step, what is the requirement of the circuit? Which item is to be protected? The first component, that is semiconductor device. These are passive components. Semiconductor device, that is this bridge rectifier, we need to verify the highest voltage that can be applied to this bridge rectifier and maximum surge current and time duration. Let's check datasheet for this bridge rectifier. It is D15XB60. Peak repetitive reverse voltage or DC blocking voltage 600 volts. Normal working current is 15 ampere. Non-repetitive peak forward current, surge current for 8.3 millisecond, single half wave superimposed on rated load, that is 240 ampere. This is the highest amount of the current which can be applied for 8.3 milliseconds. Surge current 240 ampere, 8.3 milliseconds. This is our first condition. And voltage maximum 600 volt, that is its upper limit. VRRM and IFSM. Now what are the working voltage, nominal working voltage? Our line voltage are 230 volt. AC RMS. We need to add line swell. 230 volt multiply with 110%. So 10% increase or 20% increase. It will allow a good headroom for line swelling. 230 with 1.1. These voltage are 253 volt RMS. And if we check with 120%, 230 multiply with 1.2, these are 276 volt. Now when we will select MOV, that time we will select the next closer upper limit of this voltage. Now we will check the DC voltage, working DC voltage. 253 multiply with 1.414. These are 357 volts and 276 RMS voltage to peak voltage 390 volt. These are RMS voltage, these are DC voltage. If we check AN9771, these are maximum steady state applied voltage 357. The next closer limit, that is 365. Now we need to check the surge current. One surge current applicable to the component. And what is the incoming? 240 ampere for 8.3 millisecond is the limit for this component. What is the incoming surge current? What are the voltage? If we are discussing lightning surge, 25 kilovolt, 20 kiloampere current for rise time 10 microsecond and duration 1 millisecond. Second is switching noise 600 volt, 500 ampere. Rise time 50 microsecond, duration may be 500 millisecond. Any type of EMP, electromagnetic pulse, 1000 volt and 10 ampere. 20 nanosecond rise time. This is rise time up to 90% of the pulse, that is called T1, and duration 1 millisecond. That is from 0 to 50% of the current. That is this level. 0 to 90%, that is rise time. 90%, 100 and then 50% back. That is fall time. And if there is ESD, electrostatic discharge, 15 kilovolt voltage and 30 ampere, 1 nanosecond rise time, 100 nanosecond fall time, up to 50%. That is this limit. In this chart, if we see, that is in application note 9771, applied voltage. Our applied voltage are 253, 264, 265, 275. These are voltage, and these are DC voltage. So our category will fall in this line. In this voltage value, how much current we need? From 30 ampere to 1000 ampere. If we want to consider up to 6500 ampere, which series we will use? PA series in this 20 mm package. If we want to consider 1200 to 10,000 ampere peak current, at that time energy will be handled 11 to 400 joule. LA series, ultra MOV series, 7 mm, 10 mm, 14, 20. We can select protection based on the current limit. So we will select this LA series. If we are considering 10% line swell, that time we will select this 275 volt AC. And if we are considering this one, then we can select this one, 300 volt AC voltage. And DC voltage 357, 390. So it is much better to select this one, V300 LA series. We can also select different MOVs. This from CNR series. In CNR series we can select, for example, this 300 volt CNR. Now we will select the disc size. CNR here will disc size D471K. From different manufacturers we can go to DigiKey, we can select from there. So this is our first approach, that which one we need. All four types, 7 mm, 10 mm disc size, 14 and 20. All of four working voltage, DC voltage, are 405 volts, and this one 300 volts. Then energy, we will discuss energy later on. Then there is current, 8 by 20 microsecond. In each data sheet, 8 by 20 microsecond, that means this pulse. If any pulse is rising up from 0 to 90% in 8 millisecond, and then until 20 microsecond, it will reach up to 50% of its peak. That is called 8, and this T2 20, 8 by 20. If we are selecting this one, its peak current is 1200 ampere, 7 millimeter. 10 millimeter will handle 2500. 14 millimeter will handle 4500 ampere current. This one 6500. Now this is for one pulse. Peak current 8 by 20 microsecond. In different data sheets there are different numbers for one pulse, for two pulse. Then there are varistor voltage. Here is I, current. Current will increase from this zero line to upside and zero line to bottom side, because MOV will work in both directions. When the voltage are increasing, before a certain amount of voltage, the current will remain negligible, because that time the MOV resistance is in gigaohms, in thousands mega ohms. That time it behaves like an open circuit. Then at specific voltage level, it will transfer in conduction mode. At that time 1 milliampere will start to flow from here to here. That is called V nominal voltage. That is also called V1 milliampere in both directions, forward voltage or reverse voltage. at nominal voltage 1 milliampere current will start. This time it will become active. That are V nominal minimum. If we are discussing this one, V300 LA2 will start to conduct V nominal, that is V1 milliampere, 420. These are DC voltage now, and maximum 565, that are for this series. And if we are discussing CNR series, in this datasheet Wrister voltage V1 milliampere 471K, this one 423, center value 470 and maximum 517. If we are discussing some other series, the same V1 milliampere or V nominal, minimum DC voltage, maximum. So these are DC voltage. Then there is clamping voltage, V nominal here. Here is VC, clamping voltage. Now this MOV will work in two regions. One is transient suppression, that is one pulse for specific time duration for 1 microsecond, 1 nanosecond, 20 microsecond, like that. And the second, if the pulses are striking again and again, multiple pulses are striking with the same duration, or single pulse for long duration, at that time the scenario will change. 14D471K will handle maximum 6000 ampere current. And if we see V300 series, the change in peak current, chip size 20, 6500 ampere, 14, 4500 ampere, 10, 2500 ampere, chip size 7, 420. If we are discussing the maximum surge current, 10,000 ampere surge current that can enter in this line. It is peak. For a good calculation, divide it by 2 to get approximately nominal current, 5000 ampere. The closer value 14 size is good. If we check in CNR series, maximum 6000 ampere, 14D471K is good. It will handle up to 6000 ampere for one pulse. And this one 4500 ampere. When there are more pulses, at that time it will clamp voltage at 775 with 50 ampere current. Other voltage will be grounded from this line to neutral. Here is 50 ampere current flowing in this path. This fuse might be 5 ampere, 6 ampere. So this fuse must open the circuit. If we check CNR series, 14D471K, clamping voltage 775 with 50 ampere current when it is conducting. If you see here, maximum peak current for 8/20 microsecond, that can reach up to this level. But clamping current for 8/20 microsecond, that can reach up to 50 volt when the circuit is in clamping region, in this region. When the current will flow here, clamping current will flow here, and clamping voltage are there. If the pulses are striking again and again, that will cause to produce power in this MOV. So its substrate temperature will increase. Then it will become short circuit. Before this, it was working in some ohmic range. It was damping all the surge. If the surge is high, transient voltage are still high, then the limit, that time its body temperature will increase and it will become short circuit and it will permanently damage. But at that time it will blow away the fuse. When we selected this one, how much energy will be consumed by this MOV? It is also timed calculation. 10-second rise time 1000 microsecond fall time. The same as we discussed rise and fall time. Maximum energy 10 over 10,000 microsecond, 175 joule. We can calculate this energy if we know the pulse shape, duty cycle and number of pulses. Time duration, energy for 2 milliseconds. When we are calculating that time, we need to understand this time. To calculate energy, the formula is K, that is constant, clamping voltage, current and time. K, that is constant for the pulse type. Which type of pulse is there? That is transient pulse. This one constant value is 0.637. This one 0.5. This type of pulse is peak up to 50%, that is 0.86. If the pulse is like this from peak to 50%, that time constant value is 1.4. If DC, that time the constant is 1. If the pulse is this type, that in 5 microsecond it is reaching up to 100 ampere and 50%, that means 50 ampere in 50 microsecond, that time this pulse will be calculated in two different ways: rise time separately and 45 seconds separately. 0.5, that is this type of rising edge, that is this one. This constant for this rising time. 0.5, 500 clamping voltage, 100 ampere current. If we are selecting V130 LA1 series, pulse duration 5 microseconds. That time it will consume 0.13 joule. But now we will see fall time. Fall time is this one. Pulse is falling from high side to low side, that is this one, from peak to 50%, that time 1.4 constant will be used. 1.4 clamping voltage, clamping current. 50 microsecond is full time for this pulse, from 0 to peak and then 50%. 5 microsecond is rise time, that is detected here. Remaining 45 microsecond will consume 3.15 joule. 5 by 50 microsecond pulse will consume 3.8 joule when it is clamping 500 volt at 100 ampere. That energy will be converted into this time: 10 microsecond rising pulse, 1000 microsecond for falling time. So we can calculate, we can convert that value to calculate the exact value for the energy. Typical capacitance for 1 megahertz. At 1 megahertz, when it is working in this region, leakage mode, that time 400 picofarad capacitance will be present in this line. So it will work as a capacitor, but that is very low amount of capacitance. Now one thing to understand, if we are selecting 10 millimeter disc size and we are considering the current, we can see when the current will increase more and more, that time it will allow to enter some more voltage in the circuit. At 5000 ampere surge current, maybe around 750 volt will enter in the circuit. Comparing with 20 millimeter disc size, at 5000 ampere it will clamp the voltage at 500 volt. So selecting some higher disc size, that will provide more safety, more protection, more surge suppression, and that will protect the circuit more and more. Now if we compare it with datasheet, these four disc sizes 7, 10, 14 and 20, disc size 7 is providing 10 ampere, disc size 10 is providing 25 ampere, and this one is 50 ampere and this one is 100 ampere. That means this 100 ampere will provide more low resistance. It will provide more safety in case of high surge current. So best fit component for D15 XD60. If we select V300 LA series, this number V300 LA20A, 300 LA20A is good. In CNR series, CNR 14 D471K. So we can use this one. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.